Nuclear energy, a phrase that typically evokes fear. But what are we really afraid of? My interest in this topic began during COVID. I had plenty of free time. I liked learning. That interest only continued through to 8th grade, where my capstone essay was on nuclear energy, and it deepened as I studied chemistry in 10th grade. Now, nuclear energy, in the simplest explanation, is the harnessing of energy from radioactive decay. Now, throughout this learning journey, I had one burning question. Is nuclear really the answer to our energy problems? So I asked the question, why nuclear? Well, I identified that it's safe, sustainable, efficient, and socially conscious. But some of you may be skeptical of this. Is it really that safe? Well, let's see. So, some stats. Now, this graph right here is deaths per terawatt hour of different forms of energy production. According to the UN, nuclear energy is the second safest energy production method. What about the other energy sources? Well, hydroelectric is fourth, but there are events like the Banqiao Dam collapse, which were responsible for over 200,000 deaths in Henan Province, China, that haunt the history. Furthermore, hydroelectric is devastating to river ecosystems and fish populations. Moving on, fossil fuels. They're responsible for 9 million deaths yearly, just from pollution, not including facility incidents and other things. Now, not forgetting renewables, wind is responsible for 1 million bird deaths in the US yearly, as well as other related issues. Now, even solar, the safest method per terawatt hour, has its problems. Lithium, a key component in the batteries required to supplant solar energy, lithium mining is one of the most devastating mining operations in the world, and also has a major share of its production linked to child labor. So, the truth is, everything comes with a cost. But from what I can tell, the numbers are in nuclear's favor. Less than 150 deaths have ever happened because of nuclear energy. Even the most well-known and deadliest nuclear accident, Chernobyl, was because of gross negligence. To save you from a drawn-out explanation, Chernobyl's design was inherently wrong. It was designed to produce plutonium for nuclear weapons, not to create energy. The reactor workers did not know this, which led to a misunderstanding of how the reactor functioned, leading to gross oversteps in safety policies and regulations, which ultimately the reactor failed because of. Now, even looking past that, the US Navy, which has operated reactors, over 500 reactors for more than 70 years, has never had a single accident. But why is that? We'll answer that question later. But first, we're going to look at some of the environmental impacts. So, nuclear power generates a minuscule amount of waste compared to other energy forms. For context, for all the power you will ever use in your entire lifetime, an individual, this is the equivalent size of how much waste you will produce. Compared to coal, which would require an entire ton, and all the waste that is associated with that. The only reason we're not recycling the waste, because it's 97% recyclable, is because of guess what? Money. Now, all this info seems like pretty convincing evidence to me that nuclear is the best energy source, but that's too easy. So I asked another question. Where is the nuclear energy? If it's so great, why don't we use it more often? Well, 19% of the United States power production is nuclear energy, down 2% from its peak in 2001. In California alone, there is only one nuclear power plant with 2 reactors. It's responsible for 10% of the state's energy production, but it also acts as an ecological reserve, preserving 4,000 acres of pristine Californian coastline. Now, across the US, there are only 54 nuclear power plants, while the natural gas plants, the dominant source in the United States, have over 2,500 locations. Coal, which has been drastically cut back, still has over 200 locations, with fossil fuels totaling 60% of US energy production. Which led to my central question. What is stopping the expansion of the atomic energy sector in the United States? So I had some guiding questions to help align my goals with this project, guiding questions like, what government factors are in play? Is public perception really that influential? Well, before diving into my research, I'd like to cover some of my experts. My main expert, Dr. Alexander Bataller, is a nuclear engineering professor and researcher at North Carolina State University. Dr. Wesley Frey is the McClellan Nuclear Research Center Facility Director, or MNRC, and Tom Brennan, a materials expert from Dynamism. So, I began my research, and over the course I identified that each and every issue fell into four main categories: financial, regulatory, public perception, and we'll get to this one later. So, as far as finances go, nuclear energy is quite the undertaking. Natural gas, as a comparison, has an average plant cost of about $1,000 per kilowatt. Nuclear is 7 times that, at $7,000 per kilowatt. Furthermore, nuclear takes typically 6 to 8 years longer than natural gas to build a plant, and it costs twice as much, as you can see on this graph, than natural gas, the cheapest energy source by far. Now, on top of that, but why is it so expensive? Well, despite making more than almost 20% of the United States power, it only receives 1% of the energy subsidies, a stark difference from the almost quarter fossil fuels receive and the almost 60% of US energy subsidies that go to renewables. Now, that is not the only problem. The subsidy issue has caused more than 50 reactors to shut down over the past 30 years, but it's also a lack of infrastructure. Many of the parts integral to the operation of a nuclear reactor are simply not produced anymore. I spoke with Dr. Frey about his reactor, and he told me how should a component, a specific one, in the reactor break, it's no longer produced, the reactor would have to shut down permanently. Now, even the film that the MNRC uses for neutron ray imaging has to be produced on site because their supplier shut down over 10 years ago. Now, I'll touch on that later as well. The logistical capacity of nuclear energy peaked in the 1980s and has never recovered. So, are the regulations to blame for this? Well, it's another maybe. Now, as I said previously, regulations are the key to safety of nuclear power plants. And thus, they make the processes and certifications of each power plant highly convoluted. Dr. Frey said to me that if he could have any difference in the regulations, he would have an engineer write them, not a lawyer. Now, I firmly believe this is where the disconnect lies between the Navy's nuclear reactor program and civilian ones. The Navy has a stern but simple approach. They tell you what they want, and they make sure it's the most outlined and rigorous setup there is. Now, civilian regulations are quite convoluted, mainly due to cronyism. Unqualified lawmakers have created regulations they do not understand for the sake of safety, but have in turn hurt the readability of these regulations and thus complicated the process for no reason. Now, another layer of complexity is added due to the multiple regulating bodies that all are looking to slap another regulation onto nuclear energy. By far, nuclear energy is the most regulated industry in the United States. But why do we have these regulations? Is it the fault of us? Well, it is in part due to public opinion. As I covered previously, nuclear accidents haunting atomic energy have severely hurt its perception. But what you might not know is that since the 1950s, the oil and gas industry, as well as other fossil fuel companies, have extensively lobbied against nuclear energy. They have funded smear campaigns, corporate PACs to influence regulations, and have funded environmental groups that are specifically anti-nuclear. Now, this has led to nuclear having one of the lowest approval ratings, as you can see right here, even below coal, despite the stark contrast in yearly deaths. Now, this has turned into a fodder for anti-nuclear regulation. But what is the root of all this? Well, I believe it's a bit of human condition. The source of it all. The root behind nuclear suppression is not a singular group or entity out to prevent nuclear. It's not one regulation preventing expansion, and it's not one financial burden stopping the construction. It's the culture of complacency developed around nuclear energy. Whether we are actively suppressing it or making unconscious decisions to hinder its growth, we have become complacent and have left our decision-making up to chance. Our negligence of this issue is costing millions of Americans their money, their environment, but even their lives. In the past 20 years, over 480,000 deaths have been caused by by fossil fuel emissions. Now, let's see though. It's not like the energy companies are rushing to be the start of change. The top 15 US energy companies are fossil fuel focused. This, I've discovered, is also part of the reason Dr. Frey said that the regulations are needlessly complicated. It's because the fossil fuel companies want them to be. Now, they're funding renewables like wind and solar to try and calm the public into thinking they do want change. Yet, they're quietly buying up the lithium mining industry across the world so they can have control over the next big change. Now, just last June, Chevron completed a deal securing over 100,000 acres of exclusive lithium mining rights in the United States. But this is all just what I digitally read and saw. What did I physically see? Well, this is a map of my travels. I'll go over a little overview. I started in Verdi, traveled down to Sacramento for the MNRC tour, and then moved down to Morgan Hill, where I conducted 3 days of research and experiments. I then drove all the way back to Verdi, where I stocked up, drove out to Sand Mountain, where I camped, and then the next morning conducted research at Project Shoal test site. Now, all in all, it's about 14 hours of driving plus traffic. That number's a little off, but that was over just 5 days, so a lot of driving. Now, moving on to the jewel of my trip. The MNRC is, well, a nuclear reactor. My goal for this trip was to tour a nuclear reactor. And now, this proved to be quite the challenge, as there aren't that many nuclear reactors, period. I had originally scheduled a tour at Diablo Canyon, California's only nuclear reactor that I talked about, but was unable to go due to a conflict. So, what is the MNRC? Well, it is a TRIGA, or Training Research Isotope General Atomics reactor, operated by UC Davis. TRIGA reactors are typically used for research and education and do not generate electricity. They're incredibly safe due to their negative coefficient of reactivity, which basically means they're immune to a meltdown. Now, the MNRC specializes in neutron ray imaging. I covered that before. Now I'm going to explain it. It's a form of non-destructive testing, not dissimilar to an X-ray. Now, it is the last facility of its kind in the United States. And it will soon shut down. And that's because the uranium zirconium hydride fuel that it uses is only acquirable in France, because the last production facility in the United States shut down. Almost comedically, there's a regulation stating that the fuel must be acquired domestically. Now, this is a perfect example of a pointless and convoluted regulation that serves to benefit no one. So, Sand Mountain, these are some photos. I'm not going to go in too deep on this, but that morning, after I camped, I toured Project Shoal. So I rode my dirt bike out there, and Project Shoal test was an underground nuclear test that took place on October 23rd, 1963. So I conducted research on the site. I read the EPA's evaluation, but funnily enough, the only contamination left that they deemed actionable was from hydrocarbon contamination from operating the drilling machinery. Now, I decided to test for radiation using a Geiger counter right here, and I found that the peak radiation levels on the site were at the reentry site, where it peaked at around 47 CPM, or counts per minute. Counts per minute is a way to measure how much radiation particles have interacted with your sensor. Now, typically this only detects gamma radiation, the safest and most easily detectable type of radiation, but I wanted to keep testing. So I went around the site and I got an average of about 25 to 30 CPM, well below the 50 CPM irregular range. So even the granite pile that was covering the original entry site was not at all interesting radiation-wise. And the entry site was below, so I could not do any testing on it. But all of that radiation lies within the granite formation over 1,000 feet underground. Now, the interesting thing about this, though, is that the Pony Express station at Sand Mountain, which I toured in some of my free time, draws water from a shallow well. Using that as a reference from the location of Project Shoal, we can see that all of that radiation is embedded into a mountain. This is why regulations are key. It's for protecting us from people who think they're above the law. Now, what did I conclude from this? I realized the reality of the nuclear question. All of these issues created the perfect climate for the destruction of nuclear power. We have created more problems trying to rid the world of nuclear, like storing all of Germany's nuclear waste in an unstable salt mine, simply because we wanted to expedite the removal of nuclear power from that country. That is the problem with the current regulations in the United States. They have been engineered to make the production and construction of these facilities almost impossible, while leaving the decommissioning aspect relatively unregulated. Now, there are not viable ways to store this radioactive material because we will not allow it, leading to incidents similar to the one in Germany, which is still being cleaned up. Through education, we can move past NIMBYism and the negative stigma. We can move past the iron grip the fossil fuel industry has on nuclear energy, and we can move past the incompetence of our predecessors. The time is now to make your opinion heard. This is about the future of our society. As long as our population never surpasses 10 billion, we could theoretically use nuclear energy indefinitely. Now, we need to reevaluate bad regulations, such as the domestic fuel acquisition regulation on the MNRC, among so many others. The truth is, the solution is simple, getting there is not. So, this is my essential answer. After everything I've learned, negative stigma, high financial burden, lacking infrastructure, the efforts of the fossil fuel industry, the negligence displayed by those in charge of both the regulation and operation of nuclear energy have prevented the growth of the atomic energy sector in the United States. Well, I've stood here and talked about all the stuff I wish were different, but what have I done to help? Well, as I've covered, there's the education portion, which is one of the best ways to create informed opinions. But sometimes there's a disconnect between what I tell you and what you actually see. So I decided to construct this. Now, this is a radioisotope thermoelectric generator. It runs off of americium-241. And what it basically is a miniature nuclear reactor. Don't get scared. Now, due to a variety of regulations, this is not very powerful. It produces about 0.5 volts and pulses up to about 20 volts. And it was designed and built by me. Now, all the information of the physics and everything to know, like you needed to know how to build this, is all available online publicly for free. If that does not prove to you that we understand this technology so well that anybody claiming it cannot be safe does not know what they're talking about. But that's the point. If I can build this, imagine what our greatest minds can build. Now, this leaves me with many questions. What does the future look like? Is fusion going to take over fission? Is the diversity of design of these reactors, is that a key to play? Now, I don't know. That's why I want to go into graduate research for nuclear engineering. But remember what I've told you. The status quo spells the death of our planet and ourselves. The time is now to take action. Thank you.